Good afternoon, everybody. The today's class of this machine tools and machine cutting would like to progress the topic related to shaping machine, different types of shaping machines that are being utilized for machinery machining process. Indeed, to shape in the materials of irregular shapes to the required desired shapes as per the vendor's requirements. And we would like to proceed regarding the advantages and limitations and some of the applications based upon your syllabus point of view. Coming to the structure of your syllabus, here is your syllabus concern: shaping machine, unit number 3, shaping machine, slotting machine, and planing machines. And in the today's class, we would like to discuss regarding the shaping machine. As in the previous class, we have been discussed the major principles and the components and classifications of this shaping machine. And in the today's class, we would like to progress regarding the different types of shaping machines that are being existing for commencing the operations or the materials in order to transform the irregular shape of objects to of confining of finishing and nature. Coming to the different kinds of operations that are being progressed as per the shaper operations. On the regular basis, we'll be having different kinds of shaping machines as per the weight commitments, weight considerations, different dimensional oriented considerations. The entire machineries has been classified into different groups. From that, upon confiding, depending upon the regular commencement of operations that we use it to progress for shaping the materials into a perfect dimensions as in order to fit in the assembly conditions that which we will be utilizing. Indeed, to consider a finished good. So nominally we are having different types of operations on the regular basis. The operations are here listed here, and let's see one by one. First one is the machining and horizontal surfaces, machining vertical surfaces, machining angular surfaces. So here, as per the operational parameters has been considered, these are the specifications related to it. But as per the machinery classification has been considered, the machineries will be getting default, nothing but its fittings and models in the case of its design in order to progress the shaping operations, shaper operations. As we know that different structural operations will be progressed indeed to have the finishing for surfaces, or else V type of notches, U type of notches, double V, and rectangular type of notches, spherical face of notches, etc. can be progressed with respect to the shape of the tool and the type of materials. And as we have already discussed in the previous class, related to the type of material, the type of tools will be utilized based upon its strengths and mechanical properties, the overall mechanical properties, and even the shearing conditions and the modulations related to the shearing conditions. We had a detailed discussion in the previous class as per its stress strain relations has been considered. Coming to the regular mode of operations, machining conditions that will be progressed in the case of horizontal surfaces, vertical surfaces of a work part, and in some situations fittings, particularly in the case of industries, or indeed to consider the assembly conditions also, the angular surfaces almost in the fitting conditions. So indeed to have a particular definite shape over it, this angular surfaces machining plays a major role as the best suitable to, in order to commence this angular shaping condition. The machinery should be very much flexible, that user to confide, as we have been discussed, that it's an dynamical version of machinery. Next, the machining of dovetail groove. So it's a bit different in its dimensional strategy, as we have been seen diagrammatically in the yesterday's class. That is dovetail groove. We'll be having a fixed condition of joints. One is with respect to the accept of this condition, which arrests the dovetail, particular dovetail joint. Even we have been commenced in the case of carpentry related to the workshop lab in the first year. Machining of V block in order to confide the bulk production. This V block machining plays a major role for getting the materials to be finished or shaped exactly with respect to it. And for this, nominally we is to have a permanent die shaped block that we have been utilized in order to shape in the material to a particular V shape by applying the pressure over the material with the external offenses, or suggest the tools nominally you can see. And here we are having two different conditions. That work part will be in a fixed condition and the tool will be in a dynamical position, that it slides over the work part and commencing the overall working process. And secondary, we have visualized in the previous classes that the work part will be in a fixed condition and the work part will be in a moving conditions, or else we'll be calling it an dynamical motion as per the required finishing operations to be performed over the material. Nominally, the MRR condition will be clear, particular shape will be getting achieved as represented with respect to the instructions given. In the case of this semi-automated and automated systems. And one thing should be very much clear, that three different phases of operations. First one is a conventional mode, which is operated entirely with respect to the machining characteristics operated by manual process. And the second one, it is a semi-automatic process, and 50% will be related towards the automatic strategy, and 50% is only the involvement of human effort. And the third one related to a complete automation technology, which leads to entire machinery oriented operations. So without any involvement of the human effort. That is, it related to only a single and skillful worker sufficient for operating over that particular machinery. And even moving on to a regular operations, we are having slot machining process, T-slot machining process, machining external keys, the internal keys, which are having the different typical threading or orientations towards it grooves. As we have seen very much clearly, this internal and external related to the shaft drawings in the design of machineries, DMM subject. So keys, shaft keys, and even we have drawn clearly the representations in the case of our machine drawing subject also. And the machining splines or cutting gears, machining of the irregular surfaces over the surfaces of the object. Let's look after one by one in detail the operational processes. Machining horizontal surfaces. As a diagram that represents the tool and work engagement of working process, that the tool shape is getting engaged with respect to the work part. Indeed, to remove the material over the surface of the objects that is having the irregular in conditions, that is crusts and troughs, is related to the rough surface finishing. So an uniform distribution of slices to overall work part related to the finishingness and towards its surface finishing. Nominally, this apron will be fixed with respect to tool post, and this tool post holds the tool. Based upon the working material, will be selecting the particular tool part which is confided over the work signations. A feed rate that will be adjusted manually. The work part will be fixed in one condition, and the secondary condition, it is the tool part will be fixed and the work part will be in dynamical condition. In the given example, or in the given application that is visualizing in your slide, that the work part is in dynamic motion and the tool part is in fixed condition. Now, this way, the MRR, that material removal rate, will be getting commenced and will be having an uniform structural surface finishing over the horizontal cases of a machinery that will be entire in uniform status in the case of its dimensions after getting the machinery. So before getting the machining process, it will be having different kinds of dimensions over it. But after commencing the operational process, as the standard angular representations or standard MRR process will be considered by this horizontal machining. The surfaces used to confide with respect to an uniform removal of this MRR process, and indeed to achieve the uniform dimensions to overall objects which are getting machining on it. This is the case of this horizontal surfaces machining. Come to the kind of this vertical surfaces. Here, the work part will be in a fixed condition, and the tool will be getting operated over the work part, and the movement of this tool will be considered with respect to this fixation of angular representation with respect to the apron in the shape of machinery, and manually the feeding process will be getting done over the work part by the screw that has been monitored externally. So by this, a fixed phase of this feeding will be getting considered, and with respect to the tool, the machining actions will be getting possible of conditioning this MRR process. So nominally in the case of this pictorial representations, It's very much clear that the feed rate will be giving externally as the tool which is having a particular depth of cut at the tool and work part engagement as displayed in the diagram. For example, of 2 mm of removal or 3 mm of removal of material from the parental material will be considering, and the required shape of the material will be getting obtained. Coming to the case of this angular surfaces, machining of this angular surfaces. So nominally, we had a detailed discussion related to this horizontal and vertical. But angular specifications in the sense it may be considering in the case of this obtuse type of angle or acute type of angular representations that lead to a fixed condition in the assembly status of a entire machinery, or else the part which need to be sharpened according to the convenient dimensional accuracies if some the deformations has been considered by externally applied load, or else any of the deformations that has been considered in the assembly status due to the overheating factors, due to the several factors. For our instance, in the industrial sector, if you have been considered in the industrial sector, a static fixation of different kinds of elements will get deferred in its shapes because of its overheating. So overheating in the sense how the deformations will be getting taken place. If at all the unbearable loads has been imposed over the material, then the deformations might be taken place, or else the overheating we are calling. So overheating in the sense beyond the boiling point of the material that we are being utilized in the case of this assembly conditions and reaching towards the melting point. So melting point is a bit different. That entire the material will be is ready to start into the phase transformation. So let us say an example confiding to it as a bit of boiling point. So which the over resistance of the material is getting taken place due to the overloads or else towards the temperature factors. By that, the mechanical properties internally has been get very much detailed and modeled into the entire that particular object is transferring its dimensions towards the another kind. So another kind in the sense here it may commence directly towards the plasticity of range and may lead to the ultimate tensile load conditions, even to the tensile load conditions. So here we are having three different methods for processing the machinery activity over the angular objects, angular shape, angular work parts which has been in a static mode within the industries. So we are having the taper strip method, that is nothing but that particular strip will be fixed or positioned within a particular table and job is machined over the surfaces wherever it is necessary. So the referral units will be considered as it may be of this two-dimensional or three-dimensional will be coming into a particular characterization, and from that the monitoring actions will be getting done for the tool consignments. Second method is a layout method. So here layout, nothing but the market conditions will be considered over the workpiece, that too towards a slant surface which is inclined to a particular range, that is before itself it is marked, and according to the marking has been given, the position will be given either to the work part, either in the horizontal or vertical mode of action. And later on, the work will be getting progressed at that particular drawing which has been clearly specified. Even for this, the color code also plays a major role. So what is meant by color code? Some of the machineries which are semi-automated or automated, where in the real-time field, manual involvement is restricted to a major extent. This particular condition plays a, this particular type of machining, operating conditions plays a major role. By identifying or by sensing the drawing lines or representations as per given drawing, entire this robots which is automatically operated will get guided over it for progressing the machining process. So here the shaping as per our convenience will be getting obtained automatical in an automatical or semi-automatical mode, that we can say. This third one, it is the degree parallel method. Degree parallel method. Normally we used to consider a block which is having a wedge shaped, particularly used for angular representations. Actually, it is placed over the table and the work part is positioned on it, and externally we use it to apply the pressure over the material in order to transform its shape until it gains the required dimensional accuracies or required dimensional accuracies. So this external pressure is of different kinds. It may be of an manual mode, or else a semi-automatic mode, or else the automatic mode. So depending upon the type of material, that pressurized or that particular pressure, and even to a fatigue or creep nature is a repeated type of load. Repeated type of load should be applied until we get the deformations. So due to that, there will be an positive representations over the material after transforming the material to our required shapes. And next, the secondary condition it might be having some of the defects, because our repeated kind of loadings gradually will be called as a fatigue type of loadings in our mechanical language. The mechanical properties such as strength, stiffness will be getting decreased, ductility will be getting increased. So more thermal stresses which will be getting arrested to an atomic range will be getting very much increased in the case of materials. That too, in the case of these metals, it's very much more. As ceramics, these are very much brittle oriented, and polymers, not at all accept the much load conditions. And even the universal Weiss method is being utilized for shaping processes, that way an fixed Weiss with an universal dimensions will be having an confined areas. It's a fixed strategy, and hence the surface will be getting meshed over it. And universal machinery, so it's a common to each and every phase of machining process. A lathe machine, we're having the universal lathe machine, that's the entire parts over it, and the machining conditions, operating conditions, tool fixations, etc. within that operational scenario or process will be similar to whichever place it has been shifted. Likewise towards the another process also, drilling process, milling process, reaming process, slotting process, etc. Let's have a look towards this machining angular surfaces. So here, angular surfaces not only consider the flat finish, consider the work parts or MRR condition in the case of straight line motions, but also need in different motions that we'll be calling as an countering positions, which doesn't have a particular dimensional status. So, swivel tool head method. Here, within this apron, which holds the tools and tool post in it, it supports to affix a particular angle when the surface has been identified and work part is in fixed condition. See in the example, the pictorial representation, work part is fixed here. Let us consider this as a cast iron material or the mild steel material, and utilizing the stainless steel material as a tool, and which is fixed over it. And the angular representation has been fixed over it based upon our requirement and the particular shape that has been required over the work part to be obtained up to a particular dimensions, to how much depth that particular inclination should be maintained in the operational process. It's nothing but the swiveling towards a particular direction by fixing a particular inclination and commencing the activity until we get the required shapes in that particular vertical or horizontal plane. These are the conditions. And in the case of this dovetail shapes, there's a nominally this is the shape called dovetail joint, as we have been done in the workshop laboratory in the first year, that too in the carpentry process, carpentry work in progress. So indeed, to commence this particular process, entire these three different methodologies plays a major role. So plain horizontal shape of cutting, plain vertical mode of cutting. See here, three different representations plays a major role, and the angular space of cutting. So here, even though it is angularly specified, the tool will be fixed in an angular considerations, but entire the working process, the depth of cut, by maintaining a particular feed rate with respect to the working tool, will be confined in the working zone area up to a particular extent. For example, it's the overall length, overall depth of the object, it's a length, breadth, and width. So up to a marking range, the material have to be removed by this tool. So up to which length, there's a particular length up to the drawing mark. So this is slant machining process, nothing but the inclinational condition of working process will be getting acetated. That too with an good surface finishing will be getting obtained in the case of this shaping process, shaping working process. See here, two different blocks are being necessary indeed to commence this hold up phase, and next this is an hollow section indeed to hold this particular shape. So nominally we will be utilizing these configurations at holding of the objects to a particular loading conditions, but not in a greater range, to a particular range of weights, but not a much more conditions. Coming to the special operations. So special operations in the sense you need to have the V block. So V shape in the sense almost the V shape will be getting confined with respect to a unitary tool. Even the U block will also will be considering the working process or machining process over the material with respect to a particular zone with an unitary tool piece. But A special designs need to be considered after getting this machinery, or that work part needs a basic phenomena. And even a simultaneous working process at different phases, as we have will be representing that as a multi-oriented working plan. Multi-oriented working plan. Hence, in this V block, entire in this three different holding spaces, the work parts will be fixed in particular strategy, and entire three different tools can be simultaneously progressed over the materials. The holding will be in another side and three different. There is a multi-space, and the special operations will be seen in depth furtherly. Mentioning the external keyways. So external keyways, nothing but these are very much confined over this length, continued towards the length of the cylindrical rods, almost within the cylindrical objects. As we say that from the origin, if you have been considered, it will be considered as a radius to up to the its circumference. Normally we'll be calling as radians when it has been considered from the origin point of view. Origin point of view. See, as a tool that has been furred towards it, and the spherical objects or cylindrical objects which will be arrested in the vise, and need to have a particular slots over it up to a particular depth considerations to an origin point or else towards the entire work part, that will be giving a markup. Particularly these slots will be getting done for the key and shaft basis. Indeed, to commence the rotational basis when the shaft has been key has been placed over the shaft, and the rotational characteristics for locking the nuts and doors with respect to this closing and opening in a permanent sector. Basically, drilling operation plays a major role, and later on the boring operations will be getting done for internal finishing structures, or else any of the special characters you need to have the threading orientations towards internal section, or else indeed to groove in the shapes than the drilled out conditions. So for example, in the drilling conditions, we have been having 6 mm drill bit and have done the drilling activity over the work part. And if you have to increase that 6 mm of the drill bit towards the 8 mm, then the boring activity is a preferable activity in the already having the hollow sectional work parts, in order to enhance, we'll be calling as an enhance or else increasing in its diameter. And even for the special status of working as additions also, nothing but stepwise cutting and stepwise maintaining of different diametrical strategies internally or else the externally, which are having in its diametrical deformations to be obtained as per our requirements, as per our drawings, as per our standards. So our standards in the sense as per the vendor requirements, which will be progressed in the industrial sector. See, normally we used to progress this in a two different conditions. Even here also we'll be considering with two different conditions. So internal keyways. So internal keyways, in sense, it is the tool that has been fixed over the shunt bar, and tool will be fed towards the material, and the depth of cut will be getting maintained. And moreover, the orientation will be progressed for this shaft, nothing but the snot bar which is connected to a shaft, as this work part is fixed in the bench face. For example, it is having a particular length, a particular diameter internally, if at all it is a cylindrical object, and a much more diametrical status has to be get increased. So you need to commence that activity based on one phenomena of working. And the second thing it is a snot. The snot bar will be having removing of this MRR process, material removal process, towards only one direction, that is a unidirection. And in the reverse condition, it will be having an ideal traverse motion. Because if this has been marked up here, this is the material to be progressed in horizontal mode of working up to a depth of cut of 4 mm, and initially 2 mm of feed rate will be getting given and 2 mm will be getting removed, and ideal traverse will become back over the initial position again by this tool. And second process is then secondly another 2 mm more material will be getting removed. So this is a frequent motion of this shaping machine, as you have been discussed, related to the slotting machine also. So what are the some more special operators? So in order to have the slots and its internal finishing, so already it's having the notch, and internally the circumference or else the area is finished into a different slot deformations by removing the material and constituting with respect to a single piece or single work part, constituting the entire operational process in a single work part. So hence the tool plays a major role here. The tool that will be fed over the material work part, and the material will be getting removed as per our vendor specifications. There were the T slots, V slots, double V slots, C shape type of slots. Entire in and spherical object, the rectangular representations can be marked up. Entire in the spherical objects, the internal grooves can be channeled into a rectangular specifications, or else the triangular representations, or else the pentagonal representations, hexagonal representations, so on. So as per the designed kinds of drawings that are being required for the assembly conditions of different parts, our manufacturing will be getting progressed with the help of these tools over the materials. Particularly, this is the representation of T-shaped groove to be obtained in the work part. Machining of irregular surfaces in order to concave condition with respect to an finishing nature towards its surfaces. Even the shaper machine is having the capability of machining over this counter positions also. Counter positions in the sense irregular shape of positions, irregular surfaces. So you need to get or you need to work out towards, but greater power cross feeding that is guided with respect to an manual mode of action is getting required over this counter positions need to be happen. So modally, in the case of this conventional strategy, most probably in the status of this conventional mode of working progress. So the tool, nothing but the tool should be monitored manually over the work part. Indeed to commence the material, or indeed to transform the dimensions of the existing material to the required dimensional oriented conditions.